Since January, I bought a treadmill in the hopes of chasing a 10K marathon. Come April, this treadmill is being used as a clothes hanger. We all have good intentions that sometimes don't survive reality. The same is with Java developers. We write a three-step instance of code thinking we'll clean it up later. But that never happens. Pattern matching is Java's New Year resolution that actually sticks. I am Pallavi Sonal and welcome to your journey to Java certification. With Java Goes on a Diet, Episode 1 Pattern Matching Instance of.
Here is the sample class hierarchy that we will use to understand the examples. Player is an abstract class. We have three types of players. Extending this abstract class: standard player, premium player, and VIP player. The standard player does not get any privileges. The premium player gets a privilege of free drinks. The VIP player gets two privileges: free drinks plus the VIP lounge. Here is the sample code structure of each class. Player is an abstract class. We just want to keep things simple. So we haven't defined any methods in this class. Standard class is a subclass of player. It extends the player class, but it doesn't get any privileges, so there are no methods defined in this class. The class premium extends the player class and it gets the privilege of free drinks. So we have the method free drinks here. VIP player extends the player class. It gets two privileges. So we have defined two methods here: free drinks and VIP lounge. This is our old way with lots of empty carbs. This method here, check player, receives a player object. The instance of operator validates if this player is an object of premium. Why this cast then? Imagine going to an exclusive rooftop bar. First, the bouncer checks your ID. That's what instanceof is doing. If the bouncer is satisfied, you are allowed to go to a second counter to get the wristband. So this wristband identifies you as a premium player. That's what the cast premium is doing here. Then only you can order your free drink. Now why did we need the cast premium? It's because the free drinks method is defined only for premium class, but not on the player class. The pain that we developers have to go through: check the type of the object using instanceof, then declare a variable, and then cast it, provide an explicit cast. 3 lines of boilerplate, 1 line of actual logic. Pattern matching is that smart bouncer who checks your ID, puts the wristband on you, and hands you the bottle of champagne all in one smooth motion. No queues, no hassle. Instanceof check, true. Cast an assignment to the P player, all in one line. This variable P player is called a pattern variable. Pattern matching is the technique that helps to control the flow of program by executing only the section that meets a certain criteria. I know what you're thinking. This looks like a trap. What if I try to use P player but the player isn't actually premium? Would this blow up in my face with an ugly class cast exception? Here is the beautiful part. It can't. The compiler is like a paranoid security guard. It won't even let pplayer exist until it's 100% sure the instance of check passed. Let's see how the control moves. Player is the instance of premium, true, then the casting is done. The pplayer is created, it's assigned the player object, and then the method executes and you get a free drink. But if the instance of premium returns false, in that case the entire block is skipped. The pplayer doesn't even get created. We can even level up the game by putting a guard clause in pattern matching. Notice here, after the AND operator, the check that pplayer has points greater than 500. This is like saying, are you a premium player? Sorry sir, no free champagne yet. Are you a premium player and have already 500 member points? Complimentary drinks for you, sir. This is called guarded pattern matching. This is filtering out the data even more so that if statement gets executed only for specific cases. What if you try to check instance of on null? It's like waving an empty hand at a hotel keycard reader. The reader doesn't explode. It just says, nope, no card detected. Instance of on null is always false, whether you are using it with a pattern variable or not. But no drama, no null pointer exception. Check this code, pause and think. Will this compile? No. But in the previous slide it worked. And I told it's the guard clause in pattern matching. But notice the short circuit operator here. There it was AND. Here it's OR. You can think of OR AND as a bridge with a troll. The troll asks, are you a premium player? You say, no. The troll kicks you off the bridge. You never reach the second question. So the compiler knows anyone who gets to question 2 must be premium. But with OR, it's like a fork in the road. If the first path is blocked, you must take the second path. But the second path needs a pplayer. But the pplayer was never even created. So it's like asking, are you a VIP or show me your VIP badge? If you aren't VIP, you won't even have a VIP badge to show. The compiler catches this and says, nice try, dude. But get lost now. This is an example of flow scoping. Scope determined by the flow of the program. The pattern variable type can be of the same type, subtype, or supertype of the reference variable. Now pause and think, which one of these will compile and which one won't? Starting with the first one, player instance of premium P. P is a variable of type premium. Player is an object of type premium. They both are of the same type, so this compiles. In the next one, player is an instance of player P. Now P is a variable of type player, capital P, the super type. Player is an object of premium. So this compiles. Now we come to the next one, player instance of integer I. Now here the compiler looks at you and says, buddy, Player and integer don't even go to the same parties. They are complete strangers. I'm not letting you embarrass yourself. And this is where it throws a compiler error. The last one, player instance of object O. Now object is a universal parent. Compiler can't refuse it. But it doesn't add much value because it always returns true unless this O is null. This is the end of episode 1. Now it's time for homework. Open any project on older Java versions, pre-Java 17 or earlier, which makes use of instance of and casting. Try to refactor it using pattern variables. Watch how the size of the code reduces with all the boilerplate just getting melted away. Drop a comment. What's the most verbose instance of chain you have ever written?
What if you have to write conditions for lots of player types? You could chain if, else, if, like a sad necklace. Or you could use pattern matching for switch. That's our episode 2. Like, subscribe, hit the bell, and let's keep Java on the diet.